From my YouTube channel, Electricity and Magnetism Vector Calculus, click this playlist. If you scroll down, you can find episode 68. If you haven't watched my previous video, episode 68, Uniform Block 1, please watch it. Otherwise, you may not understand my current and future sessions. Download current video source code. Show in folder, unzip it. Rename folder 69. Copy, paste it in your working directory. Open up Visual Studio Code, Electricity and Magnetism. From folder 069, double-click uniform.cpp. Uniform flag, uniform but, Ctrl V. I will drag uniform flag. I assume you have watched my previous video listed here. Otherwise, you may not understand my current session. If you learn OpenGL programming by watching my videos, you are learning something very small, really tiny. However, if you learn how I approach the challenging problems, you learn something much bigger. I read not only OpenGL Super Bible, but also OpenGL Programming Guide, also OpenGL Specification, also GLSL Shader Specification. I read all these documents and more, but still these documentations are not perfect. Many things are left unexplained, not discussed. We have to figure out many things, those that are not documented in OpenGL runtime. While watching my current video, please pay special attention to uniform block binding point using GL bind buffer base. Pay special attention to uniform block binding point using GL bind buffer base. In your web browser, you can read about bind buffer base. I will copy this and paste it here. Also, the link. In this document, copy, paste, specify the target of binding operation. Target must be one of GL atomic counter buffer, GL transform feedback buffer, GL uniform buffer, or GL shader storage buffer. Actually, I covered all three of these, but not atomic counter buffer. In your future sessions, I will cover all of these one by one in depth. In this document, this index specifies the index of binding point within the array specified by the target. Pay special attention to index of the binding point. Pay special attention to uniform block binding point, or the index of the binding point of a uniform block. This binding point is specified in the fragment shader. Uniform block settings has binding point set to 1. Pay special attention to binding point. Now I will fold it up. In this part, we have to extract block index for block settings. I will say GL unsigned int block index. We can retrieve block settings index using GL get uniform block index. The name of this function makes sense. This is uniform block. We get uniform blocks index. This function name makes sense. We provide program. We built this program and pass it here. Then character pointer, uniform block name, character pointer. Uniform block name is block settings. Then std cout blob index cpg and this blob index is not binding point. Once again, this blob index is not binding point. Blob index for uniform blob settings. Open up this command prompt. cd 069 uniform block icx cl at resp.txt, hit enter. cls I. Obviously, blob index is 0. The binding index is 1. So, blob index is not binding point. If we don't perform such experiment, we cannot know what is uniform block index, what is binding point. Sorry, I copied this function, initialize uniform block, at the wrong place. We have to copy and paste it here. Okay, in the initialize function. Now, open up, right click, response file, copy, paste. Rename release.txt, Ctrl V. This is response file for release build. We don't need debug information, so I deleted D. Then we don't need console. Instead, we can use Windows. We can also use optimization switch O2. Release.txt is for release build using Windows subsystem. We removed debug info. We used O2 optimization. Now with this, we can rebuild using release.txt. cls, this is release build. In release build, we have no debug message. Now close it. In the debug build, resp.txt, we rebuild cls I. Then we have all required debugging message. Blob index is 0. Now close it. We can close release.txt, response.txt. Now we will allocate host memory for blob settings. To do that, we need to find out the memory size of these blob settings. Here, gl int blob size. We use gl get active uniform block iv program. We provide program. Then uniform block index. Blob index is our uniform block index. Then parameter name. This parameter name should be gl uniform block data size. Then parameter semicolon. We provide this blob size by providing the address. Now std cout blob size cpg, and if we rebuild cls I, so we need 48 bytes. Now close it. std vector gl unsigned byte. I say blob buffer. We pass blob size to allocate memory dynamically. We allocate host memory for blob settings. Now we need to extract indices of these members of our blob settings. Constant gl character pointer member names semicolon. We provide member names like this with a block name, blob settings dot inner color, copy paste, then outer color, copy spaced, then inner radius, then outer radius. Remove trailing comma. Context var int member count, size of member names over size of member names, 0. lcd cout member count, cpg, and there. Now we need to extract indices of each members. gluint member indices. We provide member count. gl get uniform indices. We provide program uniform count, member count, uniform names, member names, then uniform indices, member indices. Now std cout member indices. We can simply print out member indices, cpg, and there. With this, we build again. cls I. Now close it. Please notice member indices 0, 2, 1, 3. This is not 0, 1, 2, 3, but 0, 2, 1, 3, because the member names specified here are sorted in alphabetical order. This becomes 0, this becomes 1, this becomes 2, this becomes 3. These member names are sorted, as in this result. Without rigorous experimentation, we are apt to make mistake very easily. Member indices are assigned in the ascending alphabetical order. For example, if we change it to outer supercolor, then it should be outer supercolor. This order will be changed. Currently 0, 2, 1, 3. If we rebuild, I made a mistake. Sorry. We also have to fix here. It should be outer super color. If we rebuild I, now this order is 0, 3, 1, 2. Previously it was 0, 2, 1, 3. With this experiment, we know that these names are sorted in ascending alphabetical order, then assigned indices starting with 0. I will restore it back. Also, I will restore it back. We rebuild cls I. Now close it. The indices are now restored. Please understand, member indices are assigned in the alphabetical ascending order. Such things are not documented in the OpenGL specification, which says we should not assume anything about the retrieved indices of the members of an uniform block. Now I will scroll up. We need to retrieve the offset of each members of our uniform block settings. glint member offsets. We provide member count. gl get active uniforms IV program member count member indices. Parameter name should be gl uniform offset. Parameters. We provide member offsets. std cout member offsets, member offsets, CPG, and then we rebuild CLS I. Now close it. So we retrieved offset of the members 0, 16 byte, 32 byte, 36 byte for these members respectively. Now scroll up in the private section, constant GL plot background. This is array with 4 elements 0.2f, 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 1.0f. Now scroll down. Here, auto L value reference, outer color, background, constant GL plot, inner color, 1.0f, 1.0f, 0.75f, 1.0f, GL plot, inner radius, 0.25f, outer radius, 0.5f. Previously, we defined blob buffer. Instead of blob buffer, I would say blob memory. Then scroll down, mem cpy blob memory data plus member offsets 0 inner color 4 times size of GL plot. Copy, paste, paste, paste. Now this is 1 for outer color. Now 2, this is inner radius. This should be a single plot. Now 3, outer color, a single plot. With this, we will build. Sorry, it should be address. It should be address. We rebuild CLS I. Now close it. Scroll up in the private section, GL uint vertex array object, GL uint blob buffer. Scroll down. In this part, GL create buffers. 1 blob buffer, GL bind buffer. The target should be GL uniform buffer, blob buffer, GL buffer data, GL uniform buffer size. We computed. Here, blob size. Copy, paste it here. Then data, blob memory data usage, GL dynamic draw. I will put carriage return. Here, GL uniform block binding program, block index, uniform block binding. I will set it to. I will disable this part. More experiments here in my future sessions. GL bind buffer base target, GL uniform buffer. This is binding index. Don't get confused with the blob index. We have to provide here blob settings. Binding index is 1. Then buffer, blob buffer. Control Home. At the start of this video, I said pay special attention to uniform block binding point using bind buffer base. Please control click this link. In the GL bind buffer base target, this target can be one of these things: atomic counter buffer, transform feedback buffer, GL uniform buffer, or GL shader storage buffer. In this episode, we just consumed GL uniform buffer. Here, also note that we used uniform block song, get uniform block index, uniform block binding, get uniform indices, get active uniform. I used this song in this function. For example, get uniform block index, get active uniform block, get uniform indices, get active uniform. Here, uniform block binding. In this part, we initialized our block memory, inner color, this inner color, then outer color, then inner radius, outer radius. It should be outer radius. We will rebuild CLS I